Now open the module 8 lab 1 Excel file. So this is the sample data from the Butler Trucking Company. We can see there are 10 assignments. So to create a simple linear regression, what we're going to do is we will highlight the data, which is the miles and time. One is independent variable, another one is dependent variable. So we go to the insert and then find the chart with the scalar. Okay, so this one. So now we have this scalar chart. And then we need to add a trend line, and you should know how to do it from the visualization module. So we add a trend line here. So this trend line is actually the estimated linear line. So, but we want to know the formula which is created from the Excel, right? So what we'll do is we'll right-click the trend line, and then it goes to the format trend line. We can go to the color, and we can change this dash type to solid line. And then we can click this X-axis under the Axis options. Axis options, we click the chart, and instead of the minimum, we can choose 40. Well, these are all from the visualization part, like how to make this how to make the chart looks good, right? And now we go to the gray line and remove the gray line. And all right, so now the most important part is how we can find the formulas, right? So we go back to this trend line option, and then under the trend line option, we can click the display equation on chart. So here, by clicking the display equation chart, we have our estimated equation, which is y equals to 0.0648x plus 1.2739.
It is very easy to find the R-squares using the Excel tools. So come back to the Excel we did before. We have the trend line, we have the linear equation. And then the only thing you need to do is you can right-click the trend line and click Format Trend Line. Or you can double-click, which show the Format Trend Line window on the right side. And then you just go to all the way bottom and click Display R-square value on chart. And then so that you can see the R-square is showing here. So to do the multiple regression in Excel, we can open the Lab 2 Excel file and click Data Analysis under the Data group. And then we select Regression from the list of analysis tools. When the regression dialog box appears, we firstly enter the y range. So the y is the dependent variable. Since in this case we're using time as the dependent variable, so we will enter D1 to D301 into the y range. And then for the x range, since we're using miles and delivery as the both independent variables, so we will enter B1 to C301, covering both miles and deliveries columns into the input X range. And now we have to check, since we add the B1 and C1, which is the column name of miles and deliveries. So that means we will select the label. And also we have the D1 as the dependent variable names. And if you don't have the B1, C1, and D1, you don't need to select the labels here. So you have to make sure that if we add the column names, we will select the label. If we didn't cover B1, C1, or D1, which is if we didn't cover the column names, then you should not select the labels. Okay, and then we select the confidence level as 95. This is normally how we do. And the last step is we have to click the output range. So we can use F2 or F1 as the output range. You can also select a new worksheet as the output range. Okay, and now we just click OK. So after click OK, you will see this result. So there are a couple numbers I wish you to notice and then to answer the questions in the practice. So the first question is, it asks what's the intercept, right? So the intercept is when how y changes without any impact from the x, right? So that means when miles and deliveries equals to 0, how much would be the times? So here the intercept is 0.1273. That is the predicted value of y hat when both x1 and x2 are 0, right? So it represented the baseline value in the absence of the independent variables. And then you will ask to answer the coefficient of both miles and the deliveries. So it's showing here. The coefficient of miles is 0.067182. That means for a fixed number of deliveries, we estimated that the mean travel time will increase by 0.06718 hours, which is about 4 minutes, when the distance traveled increased by 1 mile. And then the coefficient of delivery is about 0.69. Is about, if we round it up to 2, so it's about 0.69. So that means for a fixed distance traveled, we estimate that the mean travel time will increase by 0.69 hours, which is about 41 minutes, when the number of deliveries increase by 1 delivery. And based on intersection, miles, and delivery, we can come up with the estimated equation, which is y hat equals to 0.1273 plus 0.672 x1, which is miles, and then plus 0.69 x2, which is the deliveries. And to answer the fourth question, we will check here, which is that the model has a multiple coefficient of determined as r squared, which is 0.8173. So that means by adding the number of deliveries as an independent variable to our original simple linear regression, we now explain 81.73% of the variability in our sample values of the dependent variable, which is travel time. And remember how much r squared we have in the simple linear regression? So because the simple linear regression with miles traveled as the solo independent variables explain 66.41% of the variability in our sample values of the travel time, we can see that adding number of deliveries as another independent variable to our regression model resulted in explaining another 15.32% of the variability in our sample values of travel time. And this addition of the number of deliveries to the model appears to have been worthwhile. Now, since we have the formula right here, we can do some prediction. Recall from the last field model selection method, we confirmed that the multiple regression equation based on the 300 past rows using miles. So we confirmed that the multiple regression equation is the best fitted model. So we will using this model to predict the new observations. And now, if there is a new observation with 1.5 miles and 3 deliveries, the prediction values of the new observation could be, if we use the equation, which is 0.1273 plus 0.0672 by 105, which is the new miles, the new miles traveled, then plus 0.69 multiplied by 3, which is the new deliveries. So the result is 9.25, which is the predicted travel time. So we can do this in the Excel. So if you go to question 3 and copy paste the 10 more assignments and miles and deliveries into the Excel, then we can do the prediction right here. first of all, we will, under the formula, you can text equals to formula text, and then choose the cell at left of the formula, so that in the formula here can show, in the cell here can show the formula of the left cell. So for example, if we put the formula text in J23 and to cover the cells of I23, so that actually means we will show whatever formula used in I23 in J23. Okay, and now we will work on the I23, which is the time prediction. And since the formula is using intercept plus the mouse coefficient by the mouse and then delivery coefficient by the delivery, so we can put that as the formula here, which is equals to G17, which is the intercept, plus G18, which is coefficient of miles, multiplied by G23, which is the new value of the miles, and then plus coefficient of delivery, which is G19, multiplied by H23, which is the new value of the delivery. And so that we have the result of 9.25. Okay, this is how we use the formula to predict. But here is another thing. Since the G17, G18, and then G19. So these are the values should not be changed for all the predictive estimation. Do you understand that? So it should not be changed for the other ones. So we should use the same formula. And since G17, G18, and G19, they are the intercept coefficient value of the miles and deliveries. So we should use the same value for all of the formula. And to do so, we have to add the dollar signs to convert G19, G17, G18, and G19 into the absolute reference. And this ensures that when we drag down the time prediction column, these three references will not change. And so, like if we don't have the dollar sign here, and then if we drag down, you can tell that the G17 becomes G18 become G19, and G19 become G20. And so this is not what we want. So that's why we will add the dollar sign and to transform them into the absolute reference. And then we will not add dollar sign for G23 and H23 because they are the values of the predictive assignments. So we will keep that because we want that as the dynamic values to change while we dragging down. So we will keep those numbers without the dollar sign. And so as a result, the formula is the G17 dollar sign plus G18 dollar sign and multiplied by G23, and then plus G19 dollar sign multiplied by H23. And then where G23 represents the mouse value for the assignment 301, and then H23 represents the delivery values for assignment 301. And the result obtained from the equation is the predicted time for assignment 301. And then we can just drag down the cells of the P prediction to calculate all estimated predicted values for all new observations. And when the formula is copied down the column, these relative reference automatically adjust to the next row, like the G24 and H24 for assignment 302. And while the absolute reference, which is G17, G18, and G19, remain fixed. So this ensures that the regression coefficients are consistently used for all of the predictions. And now what we need to do is we can just change the time predictions, remove the decimals till we have 2. Or if you want, you can keep 1 that are consistent with the original time values. And now we have the 10 time predictions for 10 new assignments.